All right, questions? As in, are there any?
The test is still on Wednesday?
Well, that's one of the things we'll discuss today.
For 29, I had a question on the direction of the voltage that you asked us to find for master set 29.
All right, which one?
Number 1, and
Okay.
like it's you fill out the,
The direction of the voltage.
yes sir.
If you're going with the current flows, the analogy is current flows downhill. Think about water current flows downhill. So as water flows, it flows to a lower potential energy. So we can translate that into current, electric current flows in the direction of lower electric potential, or positive charge flows to lower electric potential. And so if I'm going in the direction of the current going across the 5 ohm resistor, then if the direction is in the same direction as the current, my change in potential is negative.
Which is, you want it to go to the lower, so it's trying to get to the negative side of the power cell.
Or the resistor, or if I have current flowing in that direction, you can think of it as a positive charge flow. Whether it's, even though we know it's electrons flowing the other direction. But if the current's flowing that way, this would be the high potential, and this would be the higher and lower potential. So if this is a 7 ohm resistor and this current is 2 amperes, well, from Ohm's law, I know that the change in potential is IR, so that's 2 times 7. So I have 14 volts. If I'm going that way, it's negative, because that's a lower potential, final minus initial. If that's a lower number, then my difference is negative. Or it's that way, positive 14.
Okay, so your potential answer can have a different sign depending on what direction.
And that's the same true with the current as well.
Okay, thanks.
Yeah.
And electrons flow the other way, right?
Correct. Other questions? Wait,
On master set 28, for number 2,
okay.
I was confused, it's been a minute, but I was confused how you find the current after section Z without knowing the voltage yet.
So how would the voltage affect you?
It's delta V equals IR,
Okay. What I is that?
current,
Flowing where?
and into the other cross section.
The cross section. That's what you mean by that. All right, so we have this Z is a cross section right before a resistor. All right, so I got this Z right here. And I'm asking, so we have, and I tell you what the current is, I believe. Or you figured it out. Oh, you figured it out at part A. So part A tells you that value. and I'm asking you, what is it at this value, at this place? Well, it's charge flow. If I've got, let's go back to the water analogy again. If I have 50 gallons of water flowing through a particular section right here, we'll do an overhead view. So 50 gallons per minute flowing through that section right there. If I have 40 gallons per minute flowing through this section, what conclusions would you draw about the middle?
It impeded 10 gallons per minute?
Not that it impeded 10 gallons. If it somehow stopped 10 gallons, then this would start backing up. What would explain the loss of 10 gallons per minute?
The pipe got smaller?
No, you would find, that would not do it.
Maybe a leak?
Pardon?
Leak?
Okay, so that, we could be bleeding off 10 gallons. Or, leak or some sort of reservoir which is storing it. All right, so let's go to a resistor. How do resistors store or leak charge flow?
Heat?
Pardon?
The heat?
That wouldn't impede, all right, so if it impedes it, what's gonna happen upstream?
It's gonna back up.
It's gonna back up, which means that my current's not as big as I just said it was. Now, we've already established what the current is at this point. If anything, it backs up, it's gonna affect that, but it's not gonna affect that in this problem because otherwise the problem would be different. So, what's getting impeded? Or any impeding of the current's already been taken into account, I should say that.
Flow of electrons?
Let's go back to the initial question. I have current flowing in here. Any backup has already been taken into account. That's reflected in the formula. So if there's no current that's being blocked anymore, being blocked in addition to what's already been reflected in the formula, what does that tell you about the current here?
It's gonna be the same.
Yes?
So Dr. Fox, for 2A, were you supposed to take the derivative because current is dq over dt?
Yeah.
I did delta q q final minus q initial over t final minus t initial.
Just let t go towards zero and do the limit.
Do it by hand enough. We'll get it eventually.
Yes. This also is reflected in part B in Kirchhoff's junction rule. Whatever flows in, flows out. So in the case of where there's actually a junction, current flows in, flows out, flows out. I know the sum of those two equals the sum of those two. The same thing applies here. I got a current flowing through a wire here. Whatever's flowing into it's got to flow out of it. So there's no place for the current charges to go. It's not like the resistor is building up a static charge. I hope not. A properly functioning resistor is not going to build up a static charge. Now, you're right that there is impedance going. You shouldn't use the word impedance because that has a different meaning later on. The resistor does resist the flow. It does affect it. It does cause a backing up, but that happens within a microsecond. And so that would, any measurements that we would do, that's already been done. Other questions?
On the master set 27, how do you do number 2?
Proton at rest in the uniform electric field an equipotential line of 4 volts. Well, I give you an electric field, I'm asking for a potential difference. So the relationships between the two. Whatever you happen to be using, probably should use X in some, do I use X in there? I talked about that, so we'll just make this S. And which for most of what we do, well, no, there was a problem otherwise, but all right, so we have these two relationships here. In this particular case, they give us I give the electric field, and so we're basically dealing with this one right here. I bring the second one up is because I was creating master sets, I noticed that there was more than one person who ended up with an electric field with no direction whatsoever. The electric fields have a direction. All right, so if the electric field is constant, which in this case I believe it is, unless I misread this now. So my electric field is constant. So delta V is just negative E dot ds. Negative E dot delta S. So now it's a question, E I give you, what is delta S? Because I give you the value at the origin, and I ask you the value at 1.5 meters up the y-axis.
So is it 1.5?
1.5.
No, we gotta do some.
J hat?
Is there 1.5 that changed in V?
The 1.5 is the change in S, that's the change in position.
So we have the change in position and we have E.
Yes,
So we just gotta we just gotta
Yeah.
plug it in?
yeah. So this, because you're going from the origin up to 1.5 meters. We're getting third dot? Nope. So it's plus 1.5 meters J hat times the electric field that's given. And so you're going, oops, that was sloppy notation there. Let's change that a little bit.
When you're doing dot products with, I had J hat,
Yep.
that carries over, so the J hat component of the electric field would cancel out because it's J hat. Or I mean, yeah. Or is that the part that you add? Am I confusing that with cross products?
Wouldn't that be the part you add?
So what is, dot products are telling us what? Or what does it care about?
Magnitude.
The direction?
Magnitude?
It's
Oh,
Cross product.
I'm doing a comparison of dot product versus cross product.
cross products perpendicular lines,
Yes.
and then that's parallel lines?
Yeah, it cares about parallel, so J dot J is 1. I dot J,
Zero.
K.
yeah, 0.
Wait, what? So every time you multiply an I and a J, it's 0?
If you're doing a dot product.
Okay.
So ultimately it ends up, yeah, you can distribute or FOIL if I've got two binomials here, but ultimately you end up with just, you multiply the I components together, you get a scalar. You multiply the J components together, you get a scalar, and then you add them.
And you add them.
There's no cross-fertilization between the I's and J's. They're not products.
Still points only.
Dr. Fox. I'm a little confused about how to do question 3 on master set 28.
One final comment, do realize that this is finding the change in potential. This doesn't actually give you the final answer, there's one more step. All right, so for 28, what was which one?
Kind of just getting started with like A.
Sorry, one more time, which one?
3.
3A?
Master set 28.
Yeah,
Mhm.
Okay.
I got that part, thank you though. All right, so solenoid is created by winding a long copper wire around the hollow cylinder. All right, so one of the things to recognize on this is that I talk about the width of 34 coils when side by side is 12.7 millimeters. I am not saying that we've measured the entire length of the solenoid. And a solenoid is just, as said right there, you just got a long wire that's wrapped around some sort of central core. And so we basically take a vernier caliper and set it across a certain number of wires, in this case 34 wires, and side by side 12.7 millimeters. So I've got a bunch of wires right here. Got 34 wires. 12.7 millimeters. Now these wires are touching each other, despite the way I've drawn it like that. The wires are right next to each other. So what would be the diameter of a wire?
You just divide everything by 34. Okay.
Yeah, and that'll tell you the distance per wire, diameter per wire.
And then like the cross-section area, you just use the formula for a cylinder.
Cross-sectional area of the wire, think of the wire as a cylinder. So yeah, so it's actually just the cross-sectional area is a circle.
Oh, okay, then divide that for the diameter for the length.
And then length of wire, you've got, it's copper, so you can look up the resistivity of copper. I know that resistance is rho L over A. You know A at this point. It's copper, so you can look that up. I give you R, don't I?
Yeah, you do.
I give you R. Solve for L.
For master set 27 on number 2, that was, we just solved the difference. I mean, for the electric potential difference.
Yep.
So where it's at initially, that we're counting that as initial and then final.
Yes. Yep.
So I just subtract that from the initial.
Final minus initial is equal to the change.
Okay.
The most common mistake there is students getting the change and stopping.
And then the diameter of the cylinder, is that part used in D for figuring out how many loops there are?
Yeah, because if you know the diameter of the cylinder,
Are we assuming
you
that?
know what the length of one loop is.
Oh, okay.
From part C, you know what the total length is, and so you figure out how many of those lengths could work into it.
Oh, okay.
Other questions? Okay. There was a request last week for me, there's still the question of, is the test Wednesday? I was gonna go over a test Do you wanna have that discussion after that, or do you want that discussion before that?
Let's say after.
I was gonna pick the summer of 2017, because I don't think the solution is posted.
I feel like it's been so long.
That was so long ago.
Yeah, I
Yeah.
feel like 2017 feels so long ago.
Dang, that was 6 years ago.
It'll come,
I was like 16.
I thought I was from Yellow.
I think I was in middle school.
Less than
Wait,
middle school.
what?
2017, it's 6 years
Yeah,
ago.
6 years ago.
I was 16, yeah.
Oh, okay.
I was 40.
I was 13.
That was a good year.
Wait, there's no
I
way,
remember-
how, wait,
I
hold on,
remember being really happy about that
How
year.
old are you?
19.
And
17.
17.
20.
20.
Jacob and I,
Well, Jacob, how old are you?
25. I'll be
Okay.
29 next month.
I'm 21. Wow.
All right, probably be faster if, take 3 and start passing.
Yeah.
Take,
Oh my
it's
God.
3 sheets.
Are you in the early
For us,
college?
we ride on them.
Yes, yes, you may.
Okay.
Awesome.
Are you having fun? Uh, mhm. You have your homework? Oh, you're right.
Not too old.
Mhm. Try to make sure to shave everything
Mr. McGann, did that exercise make you feel old or young? Or neither?
I'll make sure to shave
Okay.
every couple weeks, cause
I'm
I'm
here to
thinking
balance it
I'm
out.
like in my twenties or something.
I think I'm kind of in the middle. Sometimes,
I've been changing.
like, I still
gotta grow
feel
a
so
little bit.
young, and I know I'm
Haircut.
still so young.
Some couple right there.
Like, there's-
Uh-huh.
I'm like, nah, y'all gotta
There's
line
like
me up.
17 young,
So you're
and
looking
then
right.
there's like 21.
Sure.
It's
Sounds good.
interesting, how many like different kinds of people are in community college versus like standard.